Hi students, welcome back to the online sessions. Okay, so in the previous class we discussed about power signals and energy signals. Okay, after that I explained you about causal and non-causal. Actually, I had given you the definitions for causal and non-causal. Which signal is called as causal signal and which signal is called as non-causal signal. Already I explained you in the last class. So I am continuing from there itself. Okay. So now I will finish the topic classification of signals in this class. Okay. We have left only two classifications, that is nothing but causal and non-causal, and the last one is real and imaginary signals. So now I am going to explain you causal and non-causal signals. You all already know what is a causal signal because I explained you in the last class. So you all know what is a causal signal. Can anyone tell me what is a causal signal? Yeah. So a causal signal is a signal is said to be causal signal. A signal is said to be causal signal if x of t equal to 0 for t less than 0. Simple. Yeah. Let us consider the graph like this. Okay. So a signal is said to be causal signal if x of t equal to 0 for t less than 0. So this is 0, this is the t axis and this is the x of t axis. Okay. So what I said, x of t equal to 0 for t less than 0. That is, if the t value is less than 0, this side, if there is no value of x of t, for this side, if there is no value of x of t, that is, our signal x of t is present only for positive values of time. Only for positive values of time. Let us say this is our signal. Then you can say that is a causal signal. That is, there should be no signal in the left side. That is, for negative t, there should be no signal. So those type of signals are called as causal signals. Simple logic. Those type of signals are called as causal signals. Okay. Next, what is non-causal? So if the signal is present on both sides, then that signal is called as non-causal signals. So apart from causal and non-causal, there is another signal, nothing but anti-causal. So which is opposite to causal. So I explained what is causal, the signal that is present on the right side, that is the positive time. So the signal present on the left side, that is for the negative time axis, the signal is present, then that signals are called as anti-signals. So example for that one, simple. See, anti-causal. Anti-causal is, so a signal is said to be anti-causal if x of t equal to 0 for t greater than 0. So for t greater than 0. So for positive time, there should be no signal of x of t. And the signal is present only on the left side. So if a signal is present like this, only on the left side, then that is nothing but anti-causal. Okay. So you have three types: causal, non-causal, anti-causal. First one I explained about causal. Opposite to that one is anti-causal. Then what is non-causal? The signal is present on both sides. Then that is called as non-causal. So see, this is the explanation. I already explained you in the last class, so I gave a brief discussion about that one. Next. See, a signal does not exist for, a causal signal does not exist for negative time. A causal signal does not exist for negative time. So in negative axis, x-axis, there should be no concept of signal presence for causal signal, because the causal signal is presented only for positive x-axis, that is the positive time. So we should not have any causal signal on negative time. In the same way, for anti-causal, it does not have any signal for positive time. For positive time, it does not have any signal. So for anti-causal signals present only on the left side. So anti-causal signal does not exist for positive time. It exists only in negative time. Next. A signal which exists both in positive as well as negative are called as non-causal. The signals which exist in both the positive as well as negative time are called as non-causals. So I will give the graphical representations of this one. Graphical representation. So graphical representation of causal, anti-causal and non-causal. I already explained there. So again I am showing on the board. So causal only for positive, anti-causal only for negative, non-causal which presents on both the positive and negative. Simple logic. Next, causal and non-causal signals. So what is this? I already explained the causal and non-causal. Again I am saying causal and non-causal. Simple. So those are for continuous time signals. This is for discrete time signal. The concept is same. The concept is same for continuous and discrete. Where the change occurs? The change occurs only one thing. We all know that the continuous time signal is represented with x of t, where the independent variable is time t. Here the discrete time signal is represented with x of n. Here the independent variable is n. That is the only change. In place of x of t, if you write x of n, then it will become as a discrete signal. So the conditions are same. See, a discrete time signal x of n is said to be causal if x of n equal to 0 for n less than 0. N less than 0. That is, if n less than 0 there is negative side, there should be no signal. That is, the signal is present on only the positive side. Positive side. If the signal is present on both sides, then it is called as non-causal. Last one, for a discrete time signal also, x of n. If the signal is present on left side, and there is no signal on the right side, then we call it as anti-causal. Simple logic. A discrete time signal x of n is said to be anti-causal if x of n equal to 0 for n greater than 0. N greater than 0 means positive side. So for positive side there should be no signal. First should have the signal only on the negative side. So that is anti-causal. If the signal is on positive side, that is causal. If the signal is on both sides, that is non-causal. So the same concepts, here only the difference is discrete signals are represented with x of n. That is the only change. Simple. Graphs. Graphical representation of causal, anti-causal and non-causal. So there we gone for the continuous time signals. See, that is continuous. We have the value of x of t at each and every time instant. But here the value of x of n is a discrete instance. This one. We have the value at only this one. See, only this one. So we have the values of this x of n at discrete instance. Hence the signal is a discrete time signal. So I explained the concept of causal, non-causal and anti-causal for both continuous time signals as well as discrete time signals. So these are the on positive side. So this is causal. Negative side, this is anti-causal. Both sides, this is non-causal. But here the signals are discrete signals. Hence this is the concept of causal and non-causal for discrete time signals. Okay, so this is regarding causal and non-causal signals. So the last classification is real and imaginary signals. The last classification. So with this we will close the concept of classification of signals. So real and imaginary signal. Which signal is called as a real signal and which signal is called as imaginary signal. Okay, so a signal is said to be real. A signal is said to be real when it satisfies the condition x of t equal to x star of t. X of t equal to x star of t. Nothing but the complex conjugate, the conjugate of x of t. Okay, so x of t equal to x star of t. So if there is a signal like a plus jb, then the complex conjugate is a minus jb. A minus jb. If a signal is like a plus jb, then the complex conjugate is a minus jb. So if this is x of t, then x star of t, the conjugate, x star of t, the conjugate. X of t equal to a plus jb. Then x star of t equal to a minus jb. You all know this. Conjugates. So the concept is used here. Okay. Now, if x of t equal to 3, so this x of t value is 3. That is 3 plus j0. Okay. J into 0 is 0. Now, what is x star of t? X star of t is 3 minus j into 0. J into 0. That is also 3. So, the conjugate. So, if x of t is 3, then x star of t is also t star 3. X of t is equal to x star of t. So, these type of signals, we will call it as real signals. Simply, the signals which are having only real part of the signal is nothing but real signals. It consists of only real part. Okay, no? So this is a complex signal, and this is the real part, this is the imaginary part. In that signal, if it consists of only the real part, then that signal is called as a real signal. Okay. Next. Imaginary signal. A signal is said to be imaginary signal. A signal is said to be imaginary signal when it satisfies the condition x of t equal to minus x star of t. When it satisfies the condition x of t equal to, and it satisfies the condition x of t equal to x star of minus t. Simple. So first, in the same example I explained previously, let us take x of t equal to 3j. Now they have taken the imaginary part, x of t equal to 3j. Then I need the x star of t, the conjugate. Okay. What happens? 3j star equal to minus 3j. Simple. So there a plus jb x of t. Now x star of t, the complex conjugate, in place of a minus jb. Okay, so in place of a, here in place of a they have taken x of t equal to, in place of 0 plus 3j3. So x star of 3 equal to 0 minus j3. 0 minus j3. So 0 is no value. So it is minus j3. Sir, what do you need? Minus x star of t. Minus x star of t is minus of minus plus j3. Minus of minus plus j3. That is nothing but 3j. So this value is equal to this value. That is x of t is equal to minus x star of t. Here x of t is equal to minus x star of t. Then the type of signals are called as imaginary signals. That is, in a complex signal, the signal consists of, if the signal consists of only the imaginary part, then that signal is called as imaginary signal. So real signal having only the real part, imaginary signal is having only the imaginary part. So the condition for real signal is x of t will be equal to x star of t. The condition for imaginary signal is x of t equal to minus x star of t. So I explained you with the examples also. Okay. So a signal is said to be real when it satisfies the condition x of t equal to x star of t, the conjugate. Okay. So x of t 3. Then x star of t is 3, so that is 3. So this, if it satisfies these conditions, if it satisfies these conditions, then it is called as real signals, because 3 is a real one. Okay. Next, if it satisfies this condition, it is an imaginary. If it satisfies this condition, then that signal is called as imaginary signal. Now see, they have taken imaginary part of the signal and they gone for the conjugate minus 3j. So they gone for negative of that one, negative of the conjugate of that one. So minus of minus will give plus 3j. So this 3j is same as this 3j. That is x of t is equal to minus x star of t. So the signal is nothing but imaginary signal. See, note, for a real signal, the imaginary part should be 0. Similarly, for an imaginary signal, real part should be 0. Simple logic. If we consider any real signal, it should not have any imaginary part. So for real signal, imaginary part should be 0. If you take any imaginary signal, for any imaginary signal, there is no real part. That is, real part should be 0. Simple logic. For real signal, imaginary part is 0. For imaginary signal, real part is 0. So this is regarding our real and imaginary signals. So with this, we completed the classification of signals. So in this class, I explained you last two types of classification of signals. Those are nothing but yeah. So here I explained you about two types of signals. Last, it is causal and non-causal. I had given you the graphical representations as examples, and then real and imaginary. Real and imaginary. For this I gave you the example as equations. So these are well understood by showing the graphical representations. These are well understood by showing the equation representations. So for this I gone for graphical representations. For this I gone for the equations. So based on those, you can clearly able to understand the concepts of causal and non-causal, real and imaginary. So up to now we finished the classification of signals. So I explained all the classification of signals, that is continuous and discrete, deterministic and non-deterministic, periodic, aperiodic, power and energy signals, even and odd signals, causal and non-causal signals, and the last one is real and imaginary signals. With this we completed the topic of classification of signals. Okay, thank you one and all.